What is science? Science is used everywhere. It powers your car engine, launches rockets into space, and even governs the simple act of stirring your coffee. It drives the motions of the planets, fuels the stars, and forms the building blocks of everything you see. But beyond all the cool things it enables, have you ever stopped to wonder, what exactly is science? Science is our ever-evolving journey to understanding the natural world. Born from humanity's curiosity, it helps us uncover truths that lie beneath the surface of everyday life. Through science, we strip away the myths and assumptions, replacing them with a deeper understanding of reality. There are many different branches of science: chemistry, biology, geology, but physics stands apart as the most fundamental. Think of physics as the operating system of the universe, while the other sciences are specialized applications running on top. But what makes physics so fundamental? Physics seeks to describe the universe using the language of mathematics. As Galileo famously said, "The great book of nature is written in the language of mathematics." Imagine trying to read a book in a language you simply don't understand. You'd need a translator. Well, mathematics is that translator for the universe. Mathematics provides the framework, but it's through physics that we apply this mathematical structure to the world around us. As philosopher Karl Popper explains, pure mathematics and logic, while useful, don't tell us anything about the world directly. They only provide the framework to describe it. It's when we connect mathematics and logic to our observations that we begin to really understand reality. But here's something crucial. Physics, like all sciences, isn't about uncovering absolute truths. Instead, it offers the best approximations of reality we have at any point in time. The great physicist Richard Feynman once mused about the challenge of defining something as simple as a chair. What is a chair? If you look closely, atoms are evaporating from it, dust settles on it, some atoms belong to the air, some to the chair itself. So defining a chair exactly is impossible. His point? The laws and definitions we create are all approximations. They work well enough for us to build bridges, design smartphones, and send probes to Mars, but they're always subject to future refinement. In other words, the deeper we study a natural law, the falser and falser it becomes, and the more complicated the truth becomes. This is where the scientific method comes into play. Science isn't about confirming things as true. In fact, you can't really prove anything in science to be true. Instead, the process revolves around falsifiability. Here's how it works. You start with a hypothesis, an educated guess about how the world works. Then, you design experiments to test that hypothesis. If the data doesn't contradict the hypothesis, then you fail to reject it. But no matter how much data supports the hypothesis, you never declare it as true. Theories are always open for future refutation or revision based on new evidence. For example, you might hypothesize that all swans are white. You observe thousands of white swans, which supports your hypothesis. But if you find just one black swan, then that would falsify your initial presumption, prompting a revision of your understanding of reality. For a concrete example, consider gravity. Before Newton, explanations for why objects fall varied and were very mystical. Then, Isaac Newton introduced his law of universal gravitation, which accurately described the motions of planets and objects here on Earth. But then came Albert Einstein. His theory of general relativity showed that Newton's equations were an approximation, accurate under many conditions, but not all. For instance, Newton's laws couldn't fully explain the slight anomalies in Mercury's orbit. Einstein's equations provided a more precise model by describing gravity as the curvature of space-time. Yet, even Einstein's theory isn't the final word. This ongoing refinement highlights both the power and the limitations of physics and science. The beauty of physics lies in its ability to take abstract mathematical concepts and apply them to the world in a testable way. When a theory withstands rigorous testing, it becomes a powerful natural law or model we use to navigate reality. But despite its immense power, physics and science as a whole has its limits. While physics can describe the behavior of atoms and galaxies, it struggles to fully tackle something as complex and elusive as the human mind. This is where the concept of an idea space comes in. It is a model for understanding the mind using the same principles inspired by physics. Think of it as a new frontier, a space where your thoughts, emotions, sensations, and perceptions exist. Your idea space has elements, just like the physical world has atoms. But these elements, your thoughts, emotions, sensations, and perceptions, are infinitely deep, yet cannot be measured like physical objects. These elements don't interact with space-time in the same exact way, and because of this, we need a different kind of science to study the mind, the science of the first person. In the science of objects like physics, biology, chemistry, and geology, we use tools like rulers, sensors, and semiconductors to make measurements. But when it comes to studying the mind, these tools don't help because your idea space can't be measured in conventional ways. Instead, we turn to introspective practices like Zen, Stoicism, meditation, and philosophical inquiry to explore your inner world. These practices allow you to observe your thoughts, emotions, sensations, and perceptions with the same sort of clarity you might use to observe stars or molecules. Just because these inner experiences can't be seen or measured doesn't make them any less important than the objects studied in physics. In fact, life is fundamentally a singular experience that happens within your idea space, a science of n=1, a single subjective perspective unique to each of us. And until we find a way to translate this inner world through technology, computing, or even Neuralink, the science of the first person is equally as important to understand reality as the science of objects. To overlook the science of the first person is to miss an essential part of the human experience, and ultimately, to miss a key aspect of science and life itself. This series will explore the intersection between physics, the mind, and the universe. Together, we'll dive deeper into these ideas, from the enigmatic nature of black holes to the mysteries of consciousness, and uncover how your mind relates to the cosmos at large. At the end of the day, science, particularly physics, is about seeking beauty and understanding the world around us. As Henri Poincaré beautifully said, the scientist does not study nature because it is useful. He studies it because he finds pleasure in it, and he finds pleasure in it because nature is inherently beautiful. So, as we continue this journey, remember, science isn't just about facts or equations. It's the best tool for seeing the world clearly, a way of understanding both the universe and ourselves. And perhaps, through this understanding, we'll get one step closer to answering the ultimate question: what is this? Thank you for joining me on this exploration of physics and the idea space. If you found this video intriguing, make sure to hit that subscribe button and the notification bell so you won't miss our next video. Until then, be well.